Good afternoon, everybody. So we're going to get things started here. I know that some people are probably still dragging in and they'll probably walk in on this, but our next paper is with Larry Schindel. Larry Schindel. He's a senior product manager for Telos Alliance, a global leader in broadcast audio. When he oversees the company's lineup of television audio products, including the linear acoustics brand, which I have two of them in my place. Since 2015, he's worked with standards development organizations, including ATSC, EBU, to enable and promote new generation audio for the television market from the product and the technology level. Prior to joining Telos Alliance, Larry worked with Dolby Laboratories, where he managed the line of electronic sub-modules used in professional broadcast equipment manufacturers, helped develop licensing programs for emerging Dolby audio technologies, and worked with the CE manufacturers to integrate them into the consumer devices. Previously, he worked in the engineering division of audio equipment manufacturers ART, Applied Research and Technologies, and Ashley Audio. Mr. Schindel, diverse experience extends to live sound, recording, and television audio, including working as part of the audio team at the CBS television networks in New York, as well as on-site and audio production and engineering for the 5 Olympic Games. Mr. Schindel is a member of the AES, the SMPTE, and the SBE, and he holds 2 Emmy Awards. Ladies and gentlemen, please welcome Larry Schindel.
Hi. I apologize a little bit. I've had computer issues today, so we're running my slides off their laptop. So you're going to see all the ugly organizational stuff and that on the left-hand side. So please, just ignore that.
Let's see.
Yeah, true. Oh, I got to turn this on. It's on. Was working.
The switch on the side?
Yeah. This just worked a minute ago. Okay. Great start today. If you can advance the slide. Yeah, 2, please.
Is it because you took a step too far? Because it was working really
Yeah, it was working. Let me see. Yes, this wireless device is properly grounded. There we go. Okay. All right. So I'm sure most of you are familiar with all the brands that make, or at least some of the brands that make up the Telos Alliance. We build products for both radio and TV. I'm more on the TV side, so I work with the linear acoustic. We distribute worldwide distribution for Junger Audio as well, and the Minnetonka software, in addition to the radio side. I like to say that the radio side's the dark side, and TV side's actually the light side, because we come with pictures. So today this is kind of a high-level overview of the broadcast chain, where you got a sports venue and network center and the production end of things, and then you've got the transmission out to the viewer, so the emission. I'm going to be talking mainly about the emission stuff, but we'll touch on production a little bit. Okay, so kind of a quick 10-second history of TV audio. It started out as analog, had limited dynamic range and 15 kilohertz bandwidth. Then digital TV came along and digital audio. The digital audio has a much greater dynamic range, it's full bandwidth, and it supports 5.1. So along with the digital video, everybody quickly realized that to transmit out to the viewer, you need to compress that information. So, if you look at uncompressed video, HD, that's at least 1.5 gigabits per second. The audio, stereo audio is 3 megabits. So as you get to 5.1, that gets large. So that's where lossy compression comes in, be it MPEG, Dolby, DTS, whatever, AAC. Lossy codec throws away information that, in theory, you cannot see or hear. And I say that in theory because, it can get pretty bad, especially as you get through multiple generations. And with lossy audio, the way we do this is we take a certain number of samples and we build it into a data frame. And that data frame gets transmitted. That's what actually gets transmitted. So in case of Dolby, it's every 1532 samples, which at 48 kilohertz, that gives you a 32 millisecond frame. Okay. Now, with the newer generation, we're getting into what's called next-gen audio. And it's been around for quite some time now that I really think we should be calling it the now-gen audio, but it's still being adopted and deployed. COVID really kind of put a stop to a lot of this happening for a few years, but now deployments and adoption are starting to pick back up again. And what next-gen audio will give you is it brings you more than 5.1 channels, or it can bring you more than 5.1 channels, and that's called immersive audio. Immersive is a generic term, right? But there are specific brands of technologies out there, Dolby Atmos, MPEG-H, and a few others, but Dolby Atmos and MPEG-H are the two that we really focus on in broadcast. DTS does not really get adopted widely. One or two little spots, but MPEG-H and Dolby are going to be the two key ones here. That's a Dolby technology. Yeah. So I'll talk about AC4 in a couple minutes. Another thing that NGA, Next Gen Audio, brings you is the ability to personalize audio. And I'll get into this, and it works really well. It's much more efficient, and it's going to be easier for the viewers, along with enhanced dialogue. And that really kind of takes the dialogue of the program and makes it easier to understand and pulls it away from the rest of the mix, the bed mix. Okay. Next-gen audio, or at least parts of it, are adopted in over-the-air broadcast, both ATSC3 and DVB, cable, satellite, over-the-top and streaming services, Blu-ray. They all are capable and have adopted aspects, if not completely, all of the NGA functions. Okay. So immersive audio, here's a cinema. Immersive audio started in a cinema, and what you see behind me in a cinema, all those individual speakers, in a cinema, each one of those is processed and amplified individually, which sounds fantastic. I don't know how many of you have gone to a Dolby Cinema and seen or heard an Atmos mix in an actual movie theater. It's fantastic, it really is. But that's kind of hard to, they've got a rack of real-time renderers and mix engines and all this stuff that happens, and it's kind of hard to get that into a consumer's living room. So we had to make a simpler version. And that's what's actually getting transmitted today and put on Blu-rays and streaming and things like that. I'm going to talk more about Dolby stuff than MPEG-H. And the reason being is Dolby is so prevalent here in North America, where MPEG-H has not really gained adoption here yet. Just know that they offer the same features and functions, okay? So Atmos. I'm a former Dolby guy, so in putting my Dolby hat on, I'm gonna say that Dolby Atmos. Atmos is the brand name for their immersive sound experience. So whether you are listening on a pair of headphones with a virtualized instance, or you're in a cinema that can have up to 128 speakers, or you're watching a 514 broadcast of the Olympics, those are all Atmos experiences. So again, I said it started in consumer market. It's really complex. They know where each speaker is. They have real-time rendering engines in there. But we had to simplify that for the consumer use. And it adds, height channels, obviously, chance for more channels at the base layer, which is the ear level. And this can take use of channel-based audio or object-based audio, or a mix of both. And I'll get into those in a minute. You asked about AC4. AC4 can deliver Atmos either channel-based or object-based, where Dolby Digital Plus, which is what you'll find in Apple TV and Netflix and things like that right now, that's strictly channel-based audio. Okay, so it's available in all kinds of devices at the consumer side. Be it TVs, AVRs, soundbars, gaming consoles, cell phones. So the receivers out there are many, almost ubiquitous at this point. Same with these are some of the services. Many common names there, some in broadcast, some not, some being streaming and over the top. Here's some names that you may recognize. So it is being adopted on a global basis, not just in North America. Although certainly DirecTV, Comcast, they carry it. NBC Sports in the US has done the Olympics, and Notre Dame football all in Atmos. And what we see is these Atmos services or immersive services on a global basis tend to be married to a UHD program. So it's not just, we don't see too much of it with HD, although that's kind of a market demand thing. Okay, let me skip this. 514 tends to be the winning format, channel format for immersive audio. 512 is a little bit relegated, deprecated, although it is being used in Brazil. 714, 712, not so much. 916, that's really kind of a cinema format, but there may be some streaming and OTT providers that are providing content in 916, and that's primarily going to be post-produced content. Okay, channel-based versus object-based audio. So channel-based audio is really how we've worked with audio all along. And it's kind of an output format, output-looking format, a way of thinking. So, you mix to left and right, or left center to your 5.1, left center, right, left surround, right surround, LFE. So channel-based audio is how we've been dealing with audio from the beginning. Object-based audio is a little different. And it might take a little bit of thinking to get your head wrapped around it, but object-based audio is really more of an input-centric format where each audio element can stand on its own, and with that, it has parameters associated with metadata. So you have the type of object. Is it dialogue? Is it a sound effect? You have the reproduction level of it. You have its position. You have movement. You have EQ. All these things are metadata that can be associated with each individual object. And in the cinema, cinema's a great place because they have a lot more processing capability there. They typically will use like a 916 format, channel-based format, where the output channels are really a fixed object, but then they'll use dynamic objects to, for effects, helicopter flyovers and things like that. So that's really kind of a mix of channel-based audio and object-based audio. We can use object-based audio in TV, and I'll get to that in a second. Pardon me? You mix to those items. So really, object-based audio is meant for different elements or for kind of a more surround, at least, system where you can take place of that. So a typical use for an object in broadcast audio could be a different language, a different announce track. It could be 2 announce tracks for 2 different teams playing. And this ties right into the personalization. So personalization in next-gen audio really is using the channel-based audio where you can create a bed mix, right? That's your sound from the field of play at a football match. And then you have individual objects that are your announcers. So you can transmit those using something called receiver mixing on the newer receivers, newer TVs and set-top boxes, where you assign metadata to this and you allow the viewer to say, I want this bed mix with my English announce, or I want this bed mix with my French announce. Okay, and you could even let them just listen to the bed mix of the sporting match if they like the radio announcers better. But that's a business decision. These sports networks, pay their announcers a lot of money, so they may not allow that. But at a technical level, it's perfectly feasible to do. So looking at this, actually I wanted to go here. This slide, this kind of talks about what we do today, and this is a US view, right? So we have a 5.1 primary language program, and then a secondary language can be time shared with either the second language or an audio descriptive service for the visually impaired. Yeah. So what we do now is you transmit the 5.1 English on your main PID, and then either the SAP or the AD on a second PID. Okay, that takes up 2 PIDs in a transport stream, and 384 kilobits plus 128, 640. We'll just ballpark it at 640 kilobits in your transport stream. For the 5.1, but then if you're sending SAP, that's a second AC3 encode instance. It gets encoded in a video encoder or somewhere because you're not transmitting PCM. So that would be another AC3 encoder, but it happens to be built into the video encoder, be it Harmonic, ATEM, or whoever. But in that final transport stream, there will be 2 AC3 PIDs. Come on, advance. There we go. With next-gen audio, with AC4, you can put all this into a single bit stream with the metadata used to control all this. And you can send your bed mix. It can be stereo, it can be 5.1, it can be 5.14, whatever you want. And the individual dialogues. And with the metadata that's authored, you can allow the viewer what they want to select. Okay. Sorry. Dialogue enhancement is the third aspect. And this is built into the Dolby AC4 encoder or the MPEG-H encoder. There's no interaction on you, what needs to happen there. It purely happens at the viewer's house in their environment. So, and they'll have a control that they can adjust the dialogue up or down, which you can see dialogue enhancement gain and the preserved loudness controls from one of our units on the monitoring side. This is automatic. You don't have to do a thing. It's in there. Okay. It adds latency to especially for the AC4 encode, latency is much longer than that of AC3. That's why, because it's doing all the calculations to add this metadata in there. Okay. Serial ADM. Okay, this is rather new, and it's just been used in some of the first broadcasts just this month with the Olympics. Serial ADM is a new industry standard format for metadata that's next-gen metadata, next-gen audio metadata. And this is really used from production all the way through the transmission chain to your final encoder. It's an industry standard. It's not a Dolby format. It's not a MPEG format. It's going to be an industry standard. So what happens is today you could have your SDI stream, and even though 2110 is a reality, everybody still thinks in groups of 16 from SDI. So that carries over just in practice. So here you could have a 5.1 English program, a stereo AD service, a 5.1 French, and a stereo French AD service in your SDI stream today, as an example. Moving to NGA, the column in the middle, since there are now so many different things and it can change on a program by program basis, you can have a stereo program, you can have a 5.1 program, you can have a 5.14 with different announces. We need some way to signal what's happening there, and this is what SADM does. So this is a broadcaster to broadcaster metadata that really explains what the individual channels are and what they're supposed to be doing, as long as level and control and things like that with them. Let's skip this. So I talked serial ADM. This is what was used in Paris this year, kind of a workflow, where you have the metadata authoring out at the venue. It hits the broadcast center, and they can do inserts or secondary production or things like that, where they QC the audio and the metadata. They may add in a different language or a different announce or repurpose it somehow, reauthor that metadata on the way out, and then it goes to the playout servers that know how to create all this and encode all this for the proper response. And again, the broadcaster has control of what combinations they want. English with AD, you can set those things up. And this is dynamic, so this flows with the audio. So as your programs or advertisements change, it flows with it. Okay. And there was France TV's setup with serial ADM. They had this running on 2 of their UHD channels for the games, and this was a complete SMPTE 2110 workflow from end to end. The serial ADM was carried as in a 2110-41 stream, again, which is a new standard for metadata from SMPTE, but that's part of the 2110 suite. So all the audio and video and metadata was carried in 2110 all the way from the venue to their final ATEM encoders. Okay, so AC4, I've talked a fair amount about this already. One thing about AC4 is that it is video aligned. So you can route and switch that without breaking frames like you would with AC3. So if you're familiar with old Dolby E, where there's a frame based on the frame size based on your video frame rate, and then there's guard bands around that, so you switch into guard bands. AC4 is the same way. AC4 is much more efficient. So if you look at, compared to AC3, For a 5.1 plus a stereo complete main or a stereo program, so 5.1 plus 2 and a transport stream, that would occupy 640 kilobits per second. With AC4, it's 208. A 5.1.4 complete main mix in AC4 would take up 288 kilobits per second. If you add in 4 dialogues, you're at 480 kilobits per second. So you can do 5.1.4 plus 4 dialogues in the same amount of space that you would do a 5.1 AC3 stream. Yeah. So your individual dialogues are recommended to run about 48 kilobits per second each. Okay. Switch. Okay, adoption, we'll skip that. MPEG, so you're seeing all the ugly stuff. ATSC3. So ATSC3 is the next generation of the ATSC spec. It supports higher video, higher quality video and audio. It supports 4K video. It supports HDR. The audio is all NGA with each region picking whether they want to use Dolby AC4 or MPEG-H. But there, in the US, anyways, it's being marketed as next-gen TV. So that's the logo that everybody in Costco and Walmart, when they go to buy a TV in the US, will see and look for this. One thing about ATSC3 is it's no longer transport stream based. It's IP based. So it's all IP packets, which you can do some more things with. So you can do hybrid delivery, where you send out your main program audio in the broadcast and sidechain out across the internet to a device some additional content that you might be able to upsell. As an example, when I've seen this work, I don't know that anybody has completely deployed that on a wide, yeah, but I've seen it work. Okay. Okay, good. So that's one difference about ATSC3 that over ATSC1. I mentioned this, video and audio watermarking included. Audio is NGA. So I mentioned each region picks one of the 2 audio codecs. Here in North America, we've picked AC4. South Korea picked MPEG-H. Brazil's going with MPEG-H. I'm not sure some of the other countries that are adopting it, what they have chosen yet or not. Again, dialogue enhancements included, right? That's in the AC4 and the MPEG codecs. You don't need to even consider that. It just happens automatically. But the personalization that I talked about and the immersive audio can be supported in ATSC3. And again, just going back to the difference between sending out a complete main, which is what we all do today in that top line, you can still do that in ATSC3 with AC4. You don't have to change to the personalized workflow. When Korea went on air for the Olympics in 2018 Pyeongchang Games, they were the first to launch ATSC3 in time for those games. That was all stereo there. So you're not being forced into doing, forced to using all these new features, but you can. They're there for you. And the bottom line, again, going to the personalized, where you can take advantage of the receiver mixing aspect with the newer receivers, and send out a bed mix and individual dialogues, which not only provides a better experience for the viewer, right? Because if you think of somebody, at least in the U.S., the secondary language is often time-shared with an audio description service, and those are at best stereo, if not mono. Well, now everybody, including the visually impaired, can get the full surround, or immersive mix, and they can enjoy that with the language of their choice and an AD whenever it's available. You don't have to timeshare that with another language. So you would actually save bandwidth doing this, and the viewer gets a much better experience. Okay, let me skip through this. I want to come back to this one here for a second. One important thing to make, a point I want to make, is that Dolby Atmos and AC4 and ATSC3 are not the same things. They all work together, but each one of those is individual. So Dolby Atmos is an immersive experience, whether or not it's an AC4 or DD Plus, Dolby Digital Plus with Atmos. ATSC3 is the next generation broadcast format, and AC4 is the new codec. Some other applications, non-traditional broadcast applications for ATSC3, providing first responders with information, automotive applications for maps and navigation, sensors for autonomous vehicles, remote learning, digital signage. These are all ways to use the ATSC3 spec just as a data pipe, not as necessarily a media transmission. Come on, here we go. That's the adoption map for the US. I'll just skip through this quickly. Of the current deployments in the US for ATSC3, all the orange ones are ones that are up and running. The dark blue is where they have planned, but they've not launched yet. And the one light blue one down in Florida is where they're working on launching a site now. Come on. Canada. Here we go. Okay, so adoption, international deployments. I mentioned South Korea. Brazil has adopted parts of ATSC3, specifically the audio and video parts. I don't think Brazil has finalized their physical layer interface yet, which is, I think they're still arm wrestling over that there. India is looking at using it with direct-to-mobile. Mexico's focused on remote learning use cases. Trinidad and Tobago will start transmitting next year. Jamaica started last year with their service. Here in Canada, there's Orist. Orist has a lab here at Humber College. He's got some broadcast transmissions happening on air, including a site at the CN Tower now that was largely graciously sponsored by Rogers and Chorus Entertainment, sorry. And they're working with the city of Calgary to deploy the first ATSC3 smart city in North America. So that includes digital signage, and first responder network and remote education delivery and some other aspects. If you have questions about that, please ask Oren. I'm sure he'd be happy to speak about any of that with you. And that's what I have. So, okay. Thank you.
Larry, we want to thank you very much for coming to the CCBE. Appreciate it, and hopefully you'll come again. So Larry, thank you very much.
Thank you.
All right.